everyone, good evening. I guess you cannot hear me. So today we'll be having a quick intro um, into DevOps and DevOps engineering. So there's a reason why I broke the topic into two because it has become a buzzword and people tend to misconstrue both to mean the same thing. So if you can't hear me, just let me know. You can either raise your hand or just unmute directly and tell me. But again, I would like to kind of make it snappy so I can give room for more questions, as I believe so many persons would have, or some persons would have a lot of questions to share. So, okay, yeah, I'm actually not on the chat, so I'll just, that's how I prefer you on mute. So DevOps and DevOps engineering. Before I go ahead, my name is Ehis Oba. You can just call me Ehis. I mean, anyone works for me. So I'm a DevOps engineer and I'll be taking the session. So what is DevOps? So we've been hearing DevOps, 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 DevOps. So yeah. So what is DevOps? So again, when you look at a typical technology organization or an IT firm, fintech or whatever you call it, you will see that there are different teams. And the main goal of those organizations is to deliver software that meets consumer needs and solve societal problems. So how does DevOps play into this? So basically, we'll just say that DevOps is a software development methodology. So it's like a concept, a framework, or should I call it a framework like we have Agile and Mint. So it aligns IT development. So DevOps is aimed at breaking organizational silos. So there's this concept of organizational silos whereby different teams tend to do whatever they are meant to do in isolation. So which means that there is no shared purpose or understanding, which means there would be friction between or when interests merge. Take for example an operations team and a software team. So the operations team, they are the guys responsible for interacting with customers, setting up customers on platforms and the likes. And the software team are the ones building those products that the operations team handle or work with the customer on. And there is no frequent collaboration between the operations and the development team. Imagine whereby the customer will tell the operations guy or the IT operations personnel that we need this feature, we need this feature. But because the development team, they have a different goal from what the operations team is going to present, that leads to what we call decisional silo. That is what we call silos. Normally, the IT operations team and development team are supposed to converse daily, and that's what led to the concept of agile methodology and DevOps. So DevOps is basically a framework of where we integrate people, processes, and tools. And the goal is to what? Enable software deployment or whatever you can call it code. I mean, softwares are made up of code in a very robust and automated manner. So, which means that DevOps play a very critical role in the modern software development lifecycle. So, high-performing organizations, they are measured by the way and amount of changes they release daily. So, yes, DevOps is central to those activities. And basically, it's like an engine that grows or an engine that revolves between every member of the IT operations team and the development team. So we know that development team is typically made up of the software developer, the software engineer, the QA engineer, and who else? And the DevOps engineer, apparently. So now, again, summarily, DevOps is just a set of practices to break down the silos between development and operations teams, basically focusing on collaboration and efficiency. So that's why if you are digging into or digging more into DevOps, you will hear more of agile methodology where we talk about where you talk about customer interests or collaboration over documentation and so many talks. Those principles of agile methodology, that is what DevOps is trying to practicalize or bring into the real sense for organizations, just for one thing, code deployment and robust in a robust and automated manner to meet, consumer goals. So because people like to call everyone DevOps, you're a DevOps engineer, they call you is DevOps. DevOps is DevOps. So they are different. So I like to get the little facts right, the buzzwords and the phrases and the like. So DevOps is a broader cultural philosophy. So it's not DevOps is different from DevOps engineering. I mean, a lot of us here are either DevOps engineers or we want to be we're aspiring DevOps engineers. So that is what we are looking for, or that is what we are, DevOps engineers. But what guides what we do, the implementation of the DevOps culture is where DevOps engineering comes in. So I don't want to read from the slide. So I may just have to go through it. DevOps is a broader cultural philosophy and a set of practices that aims at unifying software development between dev and operations team, as a summary. Engineering is the actual practical implementation because DevOps is a set of principles. I mean, moving forward, we'll see the basic principles of DevOps. There are more than that, but I mean, those are the revolving or those are the building principles of DevOps in general. So engineering is like the practical implementation of DevOps principle through specific technical roles and responsibility. In subsequent sessions, we'll go more technical or we'll go technical. So that is where we they dig into DevOps engineering. So that's why this session is basically an intro into DevOps and DevOps engineering. So we have DevOps principle. We talk about continuous integration. So what is continuous integration? I mean, we have an idea. If not that the session was short, I would have loved a more interactive session, but again, I can make do of this. So DevOps principle and practices. What is continuous integration? So continuous integration is more like pushing code changes. So you have a Git repo or you have a software, a repo that houses the code logic behind the software. The ability for someone to continuously integrate, I mean, it is iterative and incremental development. That is what that was about. So continuous integration, merging more code changes to that is already existing, testing that particular. So you want to add a feature to a particular application. You are definitely going to write some code logic for it and adding that to it, continuously doing that without any hindrance. That is where DevOps comes in. That is what we call continuous integration. Continuous testing, where the QA engineer continually tests changes that are being integrated into existing ones. Continuous delivery involves continuous deployments, meeting customer goals, and the likes. Then continuous operation, that's what we talk about, monitoring and feedback. Then infrastructure as code. So continuous integration, we have the two major players in the IT team there are the DevOps engineer and the software engineer. Continuous testing, the QA engineer and the DevOps engineer and the software engineer. Continuous delivery, the DevOps engineer. Continuous operations, the DevOps engineer empowers or bring the tools for that, and empowerment comes up. He empowers the people or the site reliability engineer. So because we know in an IT organization, we have SROEs, we call them site reliability engineers. So there's what we call site reliability engineering. Those guys monitor application and softwares. The tools in which they use to monitor, they are empowered. Those tools are brought or are set up and managed by DevOps engineers. Tools which we'll look at subsequently. Then infrastructure as code. So the DevOps engineer, what do we mean by infrastructure as code? I mean, I believe personally that for us to build or continually maintain immutable infrastructure, an infrastructure that cannot easily break, it means that we have to handle that infrastructure at a very abstract layer, a layer which we can control every action and event. How do we do that? Code logic. So today I can decide to say, okay, I want to make sure that all Route 53 records, all fully qualified domain names that are created on AWS today, someone doesn't have to go there manually and create that record. What do? I set up a repo, use Terraform to write out the code logic for that, such that anybody that is trying to create a domain name, let's say so and so at nigeria.com or nigeria.org, raises a pull request, it goes through approval process, through audits and approval before it gets merged, and it's automatically reflected there. That is infrastructure as code. So which means that I can control everything I need as regards a Route 53 record or a DNS record on AWS. So infrastructure as code is more than that. Talk about infrastructure as code as regards networking and so many setups. CI/CD pipelines, infrastructure as code. Instead of doing step-by-step shell execution, you just write let's say, like 1,000 lines of code to handle every event and every action on the CI/CD process. That is infrastructure as code. So we want immutable infrastructure, an infrastructure that doesn't break, an infrastructure we have total control over. Hence, that a practice of DevOps, which we call infrastructure as code, popularly known as IAC. So they are more into that as subsequent sessions comes up. And I mean, if you have any questions, just jot it down or we'll take it after the class. Then these are basic principles of DevOps. They are moderates, continuous operations. I mean, like I said, monitoring using the ELK stack, LGTM, and the likes. Continuous delivery, which is deployment, rolling out changes, making configurations in production or configurations affecting customers. I mean, it's a continuous process. How does the DevOps engineer get involved in the continuous testing process? Instead of the QA engineer doing everything manually, you automate it, add it to the CI/CD pipeline or the CI/CD process. More like, instead of doing this manually, as the CI/CD pipeline is running, after the Maven build, make sure there is an automated testing segment to shove off. I mean, the goal of DevOps or platform engineering, as we are, or we call it now, DevOps and platform engineering, they are two different things anyways, but the goal of it is self-service. Make everything as easy as possible from the click of a button. That is enabled through infrastructure as code and continuous everything continuous. Moving on, we have some popular DevOps tools and automation. These are just like a few of what we have. So if you go online today and you go and you check Google and talk about DevOps, you will see so many. So today I will just boil on the most popular one, or the most popular, the ones a lot of people know. So I didn't want to mention each of the tools. I wanted to group them under specific actions, or should I call them actions or specific concepts? No, specific activities. Yes, specific activities. So we have containerization technology. Today, we have what we call Docker. Containerization technology, I mean, let me just use a popular buzzword we use. Build once, run anywhere. So today I could literally write a Java application, a Python application, and build it in a container and push it to my own private registry or my Docker Hub account or anybody's Docker Hub account, such that I can run that particular application in any platform, be it on the DigitalOcean Droplet, an AWS EC2 instance, an Azure virtual machine, a Google VM, a GCP VM, or in Kubernetes environment. So that is the essence of containerization. Again, you know the way ships are. That is why I kind of put some few logos around, logos that some of us or a lot of us are already used to. Logos like Docker, where the containerization is more like you put a particular thing inside a container and you ship it anywhere. So long that platform supports Docker, it has the configurations needed to support Docker, you are good to go. So we have examples. Popularly, we have a popular one called Docker. We have another one called Containerd. We have another one called Podman. We have another one called CROI. There are many. This is just one of many. We have another one called LXZ and so many other things like that. So, like I said, they all what's it called? They are all based on a particular specification. So today we could use Docker in Kubernetes and different environments. We could run Docker as standalone, but most likely we mostly prefer Containerd for Kubernetes environments. I mean, we can talk about that more when we are going more technical, but we also have Podman CRI. So long they meet the runtime and image specification, we are good to go. We have continuous integration tools. We have the guy popularly known as Jenkins. We have GitHub Actions. It's supposed to be an S here. My apologies. Then we have Bitbucket pipelines and many more. Many more. We have Circle CI. We have a lot of them. So we have Circle CI. Yes, Circle CI is also a very popular one. These guys or these tools enable us to build depending on the tool or the framework we are using. If we want to build Maven, build Gradle, build a Python project and the likes. These tools are the guys that compiles, that gives us, like, they automate the compilation process of our applications. And I mean, these continuous integration tools enable the compilation process. And when you containerize that particular compilation or the artifacts, let's say you're building a Java project, you're expecting a jar file. or for Python.py or for .NET.dll files and the .nupkj files and the likes, you can wrap them up inside this particular container and ship them anywhere. So it is platform, should I call it platform agnostic? That's what Docker. So again, I'm trying to go back to containerization and link it to continuous integration, more like platform agnostic. So long the platform supports Docker. Doesn't matter. And you don't need to, configurations too. So if you want to run the Java application bare metal, you would need more configurations. You may be more detailed when it comes to configurations, such as dependencies and what have you. And of course, virtualization, because you are trying to run a different platform on another one. So sometimes we use virtual machines. So virtual machines run on the base OS. So doing that can be very, very burdensome. There's something they call it, is it a circle of hell or something? Very worrisome, because when you want to scale, let's say scale, upgrade version and the likes, it becomes a challenge. So hence containerization. You have automation tools like Ansible, Chef, Puppet, Rundeck and the likes. With Ansible, you could configure, run maintenance on your Kubernetes cluster based on whatever you want to do. You can use an Ansible script to prep a particular virtual machine, set up Kubernetes in the cluster. Ansible can do that for you. Chef, you can use Chef for deployment of VM applications. Applications like .NET applications, .NET framework applications, actually, .NET framework applications. You can use Puppet to do the same thing. So it depends on your use case and your organizational needs or whatever you want to use it for. Again, these are a lot of tools which we as DevOps engineers get to interact with day after day. Then container orchestration platforms. Again, so remember we have containerization technology. So imagine I have a Kubernetes cluster of over 200 nodes and running over 500 deployments. An example. And I know that one particular pod, so a container is wrapped in a pod in Kubernetes. So the smallest unit or the smallest object in Kubernetes, we call it a pod. Now, inside that pod, you have a container which you've built, Docker-based or containerd or wherever you want to use, or the container or the CRI platform, also the container runtime interface you want to use. Depending on whatever you've built, you can decide to run an application inside the particular container. Let's say one particular container or one pod now, in this context, cannot serve 10 million customers. What do? You need to scale up. So with Docker, you have to replicate containers, replicate it on different virtual machines. So that becomes very worrisome. Imagine you have over 1,500, you need over 1,500 containers to actually run in the pod. Are you telling me you're going to have to set up in what's it called? About 1,500 VMs, or you have to take up the task of Docker networking if you want to set up a lot of Docker containers in one particular VM. So that becomes burdensome. That is where we have container orchestration platforms, such that I could literally wrap my application in the manifest file, or the image, wrap the manifest file, covers all the configurations you need for the application, and you deploy the application, which is running inside the container within the pod in Kubernetes. So if you want to easily scale, you can easily scale from one pod to 100 pods, depending on your infrastructure requirements or your infrastructure strengths. You can easily scale rather than having to do a lot of burdensome work when you are running Docker bare metal. So that is why we have container orchestration platforms. One of the most advanced is actually Kubernetes. Docker Swarm is less advanced. You could read up on it and we could go deeper subsequently. For most organizations, a lot of organizations, they use Kubernetes. We have OpenShift too, which is equally advanced. But Kubernetes is one of the most popular. So yes, is orchestration, controlling a lot of containers, grouping them. So in further technical sessions, we can talk about Kubernetes, talking about Kubernetes objects and the like. So this is just like an intro, basically. Then we have monitoring and logging platforms. Okay, now the software engineer has built his code. The DevOps engineer, it has gone through the pipeline. The DevOps engineer has built and it has gone to production. And now it is in the hands of the operations team to configure, onboard, and work with customers. Now we want to monitor requests, actions, metrics, details about our application. How many requests were sent today? To what endpoints? What response codes? Is it 200, 500, 404, and the likes? Why are there 404s? What is it talking about? Is the pod maxing out of memory and CPU? Is there CPU throttling? Is there OOM out of memory error? How do we know this? It's all about monitoring and logging. So for monitoring platforms, For metrics, we popularly use Prometheus and Grafana and LGTM. I mean, LGTM is low-key, Grafana, Tempo, and Memo. So Grafana is in LGTM. For logging, we use ELK, Elasticsearch, Logstash, and Kibana. So, I mean, you could also do metrics on Kibana depending on your implementation. So if you are implementing a different monitoring solution, you could visualize it on Kibana. Let's say you are trying to do an application performance monitoring, probably using OpenTelemetry or something like that. You can easily render it into Kibana and you get metrics too from there. So again, it depends on the skill level, requirement, infrastructure requirement, and business context. That depends or that determines which of these platforms you are going to use. Then moving on, let me hurry up. I mean, I think I have less than 20 minutes. So now we have what we call a DevOps lifecycle. So DevOps lifecycle is basically what I've said already, but putting it into perspective or putting it in one page and let's see it. The first thing is plan. So there's this thing for organizations that do agile. So I mean, some of us can take our time to look up agile later. For those that do agile, we have different agile principles. We have Kanban, Sprint, Scrum, and the likes. So there's a stage where they do planning. They can call it sprint planning or whatever planning they call it. So that is where they define goals, requirements, and strategies for the software development project. That is where the operations team or the operations product manager comes and tell them that, okay, this is the feature we want. This is what customers are looking for. These are let's say for an existing software, not a new one now. If it's a new one, they will come with market research and plans, the architectural plans and the like. That is the first stage. The second stage is implementing. Now, controlling those requirements or breaking those requirements down into code logic, adhering to the best policy and version control system. Obviously, you are using Git, so version control system is automatically enabled. Sorry, one of the most important DevOps tool I should have added was Git. Git is very, very important. SCM, source code management. So coding is the next stage of the DevOps lifecycle. Then build after you've coded. So after the developer has written his code logic or anyone, the engineer has written his code logic and pushed or tested locally and pushed, it needs to build and package. So like I said before, if you are building a Java project, you have to package a Java artifact or a .wav file, a web archive, depending on your project or whatever you want. Again, it all depends on business context and requirements. Comparing the packaging to a deployable artifact, that artifact is what you will run and build in a container. And you can either deploy into a container orchestration platform like Kubernetes, where the Q engineer will run his automated test, engage those instances, or engage the new version that has been deployed. And if those tests passes, it goes into release or go through change management and goes to production. If it does not pass, it goes back to code and build again. So continuously. So it's a continuous process. It's a continuous process. Then we have Then we have the release aspect, which is deploying to production environment. Production environment is where our software is readily available for consumption by the customers. Then we have operation, monitoring and logging, like I've explained. Operation, monitoring application in production, sharing is available and performance. I mean, it's all the same story I've mentioned already. Monitor is performance data, identifying issues again. So talking about metrics and application performance. Then let me quickly move on because I have limited time. Then again, this is like the DevOps lifecycle. You code, you build, you test. I mean, it all starts from planning. Plan, you code, you build, you test. Then you release, then you deploy, you operate, you monitor. Based on the outcome of monitoring, you plan again. If the customers need features or they are having errors and bugs, you plan again, you code, you build. So it's a continuous process. That's why it's a pipeline. The continuous process. And these are the tools. These are some of the tools. These are not the tools. These are some of the tools that empower this DevOps lifecycle. Again, so benefits of adopting DevOps. So before now, when you have someone that will go and manually go and be doing everything one by one, and before you take a particular software that was built, let's say 3 weeks ago, production, it will take like 2 weeks because of configuration, setups, and the likes. If you adopt a DevOps approach where you automate and set up immutable infrastructure using code logic and the likes, you are going to mean that your product will get to the market faster. Today, I know some organizations where you can build today and push with production today. That's based on the work that has been done by the DevOps team. It wasn't like that before. So again, when you are going deeper into DevOps, you will get to a stage where we'll talk about DevOps metrics, DORA metrics. Deploy DORA metrics are metrics used to measure DevOps performance. I mean, high-performing organizations have very favorable DORA metrics. I mean, the frequency at which they release changes and the lead time of changes. So if your deployment lead time is like 7 days, 10 days, 15 days for a particular change that has been built to get to production, that's very bad. So again, that is where monitoring comes in. So that is a point for a DevOps engineer to improve upon. So again, the process owners for the CI/CD process is the DevOps engineer. However, there are different actors in that process. But the goal of that process is to get to market faster. So as you are going into DevOps, you put that in mind that your goal is to make everything better, automate, automate, automate. That's why sometimes we call DevOps a culture. So one of the authors of the DevOps handbook mentioned categorized DevOps into an acronym called CAMS. We'll talk about culture, adoption. I mean, it's a whole lot of story. So again, culture is a very big part of DevOps. That's why you see some people, they call it DevOps culture. So again, it is all for what? Improvement. That's why you hear continuous improvement. So improved quality. So take, for instance, where you've automated testing and you have a QA engineer constantly testing code changes that are being released on a daily basis. It means that the goal of quality assurance is to what? Ensure quality. I mean, improve quality and ensure quality. So it means that the report, because of automation, report time or testing time reduces. That means faster tests. Tests can be done faster and report and results can be gotten faster, which means improvements can be made faster, which consequently will lead to improved quality of software products released. Enhanced collaboration. So with the DevOps being the process owner, which means that the QA engineer, the software engineer, the operations personnel, they would always interact with the DevOps engineer or they will always be on calls and meetings. It leads to what? Enhanced collaboration because the whole process is now like a pipeline. Everyone is involved and everyone is like a principle of shared responsibility. Everyone knows why they are there and they put in their best. So I'm trying to save off like 2 minutes before this session finishes. The increased efficiency. Again, when you've done first, second, and third, I mean, this is inevitable. This is totally inevitable. So I would not want to dig deeper into that because I mean that is what it is. Then challenges and considerations. So again, so this would be more like for the personnel. The previous one I talked about is the general benefits of DevOps and what you should have in mind as a DevOps engineer, what you are meant to do. The next one is challenges and consideration, which is based on more on the personal level, skill gap. So in DevOps, we have a lot of tools, we have a lot of technologies we adopt, we have a lot of languages we get to interact with. That's code language, that's software programming languages. So skill gap can be a big thing. So that is why, as a DevOps engineer, when you talk about continuous improvement, continuous testing, continuous operations, continuous deployment, continuous collaboration, just add personality to it, continuous learning. Because again, it's a continuous process. So new tools are coming out. You see cloud native technologies coming out day in, day out. And as a DevOps engineer, if you are very, very ambitious enough and you want to contribute to those projects, it means that you have to keep on learning. So just add to the C's of DevOps, to the 5 C's of DevOps, continuous learning, and you'll be fine. So that means you are continuously learning, and that will help to bridge the skill gap. As some persons, because I mean, as a DevOps engineer or someone aspiring to be a DevOps engineer, it's always very, very nice to have or to have knowledge of software development. I mean, writing code. So yes, if you have that, it kind of helps the skill gap, but it's not enough because you are going to interact with a lot of technologies and integrate them. Technologies that may not even normally integrate with each other. You have to find a way to find a common ground to integrate them. Then we have tool complexity. Some tools are very, very complex. Talking about Chef, Puppet, some of those tools are complex. So how do you handle that complexity? That's one of the challenges. Again, it boils down to skill gap, experience, and conversation and collaboration. Because as a DevOps engineer, you should constantly collaborate and converse with your co-DevOps engineers. I mean, there are people who are adopting technologies that are not being adopted in the organization where I work. So I interact with them, we talk and see what is going on, how we can make our own better, how we can change their use case or improve their use case and use it for myself. So if you have, I mean, that's why they have different DevOps community, we have local hosts and the likes. So again, it's all collaboration and conversation helps in this skill gap. But again, you have to be ready to learn and continuously learn to continually bridge the skill gap. Same applies to tool complexity. You have to be open, collaborative, and very communicative. Then security considerations. So again, security is a very big part of the CI/CD process, and as a DevOps engineer, security is very, very important. Talking about security in the build process, whereby your code has to be scanned, security scanning and software quality scan. They're always very big because we don't want to release a product into production that will expose our customers to harm or to digital, to fraud and the likes. That is where security comes in. Again, that is where another aspect of DevOps comes in, which we call DevSecOps, because security is a very big part, and we all know that security is shifting left, and we all have to be, the tech space is rapidly evolving, new technologies coming out, so it has become even more burdensome maintaining security standards. So yes, it's a lot, but you always have to consider security, whether be it on the container orchestration platform or your CI/CD pipeline, security must be there. So the tools for that can be discussed subsequently. So again, that's the summary. I mean, my time is almost up, so we may even have to join back just for the question and answer segment. So if you have any question, please just go ahead and ask. I have 1 minute, 30 seconds left for this particular session. So anyone with a question can drop down the chat or just unmute and let me know. That will help. So do you need basic programming skills for this? So as a DevOps engineer, you're going to write Linux. You're going to write shell scripts. You're going to write, at some point, write Python, Java, depending on the use case. So again, remember IC, infrastructure as code. So at least you need to understand programming. You need to know data types. You need to know basics of programming. You need to know how to declare a variable, all those many, many stories. It will help you. It will make you a better DevOps engineer. It's not necessarily needed for you to be a DevOps engineer. But again, you have to interact with programming languages. So yes, I would say personally, I mean, you need programming skills for it. You need programming skills for it. Because if you are, yes, the class is recorded. Because if you are a DevOps engineer interacting with tools that may not suit your use case, sometimes you may want to modify the tool. We have a lot of open source projects out there that you personally modify to your organizational use case. You can't do that without programming skills. So yes, you need it. You need it. Just learn the basics and you learn as you go. You learn more as you go. So
Okay.
yes.